Okay, so get this right. Imagine trying to separate like oil and water and sand.
Oh, yeah.
Sounds messy, huh?
Yeah.
But what if I told you there's this like invisible force that can help you do it uh, cleanly and like super efficiently?
Huh?
That's where density comes in.
Okay.
It's way more than why boats float or rocks sink.
Mm-hmm.
It's like a hidden key to like understanding how our world works.
Yeah.
So today we're going deep, deep, deep into density, and our main source is this really interesting educational resource about the Density Slash Applet by 50T.
Yeah, this applet's used to teach students about density, mass, and volume
Uh-huh.
in a really interactive way. They can
Yeah.
create these virtual objects and play with their mass and volume,
Yeah.
and see how the density changes.
So before we get into the applet, let's set the stage a little bit.
Okay.
When we talk about density, what are we really talking about?
So at its core, density is like a measure of how tightly matter is packed together. It's about the relationship between mass, how much stuff an object has, and volume, how much space it takes up.
So like a bowling ball and a beach ball might have the same volume,
Right.
but the bowling ball feels way heavier because it's packed with more mass
Exactly.
in the same space, right?
That means the bowling ball has a higher density. And this concept goes way beyond just like feeling the weight of things, too.
Yeah.
It's crucial in fields like engineering, where knowing the density of materials helps us design, well, everything: skyscrapers, airplanes.
The resource mentions that the Density Flash Applet helps students figure out the formula for density themselves, which is, I think, pretty cool.
Oh, yeah, it's neat.
It's like solving a puzzle.
It is. And the formula itself is pretty simple.
Okay.
Density equals mass divided by volume.
Gotcha.
It's like this fundamental relationship that helps us understand why some objects float while others sink.
Okay.
For example, if an object is less dense than the fluid it's placed in, it will float.
Right.
So think about a giant cargo ship, right?
Yeah.
It floats because its overall density, including all the air inside, is less than the density of the water.
Makes sense. And the resource also talks about this thing. It's called measuring volume by displacement.
Uh-huh.
What's that all about?
So that's a really clever technique where you submerge an object in water
Okay.
and measure how much the water level rises.
Yeah.
The amount of water displaced is equal to the volume of the object.
Right.
And it's a really practical way to figure out the volume of irregular objects, which can be tricky to measure directly.
That makes sense. The resource also mentions something called the Gold Wreath Project.
Yeah.
What is that?
So it's a virtual experiment in the applet
Wow.
where students, they have to figure out if a gold wreath is actually made of pure gold using density calculations.
Interesting.
So they have to apply their knowledge to solve a real-world problem.
Oh, I like that.
It's like a scientific detective almost.
Yeah, it takes the concept of density and turns it into something engaging and fun. And speaking of real-world applications, where else do we see density at play in our daily lives?
Oh, density's everywhere.
Yeah.
Have you ever noticed how oil and vinegar separate in salad dressing?
Yeah, the oil always seems to float on top.
That's density in action.
Okay.
Oil is less dense than vinegar, so it rises to the top. The same principle applies to ocean currents.
Wait, really? How does density affect ocean currents?
Variations in water temperature and salinity create these density differences. Denser water sinks while less dense water rises, creating a continuous circulation that drives ocean currents.
That's fascinating. I always thought ocean currents were mainly caused by wind.
Right.
So we've got oil separating in our salad dressings and giant currents swirling in the ocean, all thanks to density. What else?
Well, understanding density can even help explain why some types of wood are better for building than others.
Okay.
Denser woods like oak are stronger and more durable, making them ideal for things like furniture.
So the next time I'm admiring like a sturdy oak table,
Yeah.
I can appreciate the role density played in its creation. It's amazing how this one concept connects so many different things.
It is, and that's just scratching the surface.
This is already blowing my mind.
Yeah.
I'm curious, though. What about the applet itself? What are some of the key learning goals it aims to achieve?
Well, one of the main goals is to help students understand the relationship between density, mass, and volume.
Okay.
They get to manipulate these variables in the applet and see how they affect each other, which leads to a much deeper understanding than just reading about it in a textbook.
That makes a lot of sense. So instead of just memorizing formulas,
Yeah.
they're actually getting to experience how density works, like in a visual and interactive way.
Exactly. It's about learning by doing.
Mhm.
Another important learning goal is for students to be able to calculate density using the formula. The applet encourages them to derive the formula themselves, which helps them solidify their understanding.
That's a great way to reinforce the concept. What else?
Well, the applet also introduces the concept of measuring volume by displacement, which we talked about earlier. It provides a visual representation of how this technique works, making it easier for students to grasp.
So they can actually see the water level rising as they submerge a virtual object.
That's right. It makes the concept much more tangible and helps them connect it to real-world applications.
And then there's the Gold Wreath Project,
Yeah.
which seems like a fun and engaging way to apply what they've learned about density.
It is. It challenges students to use their knowledge of density to solve a problem, which is like a key aspect of scientific thinking. They have to think critically, gather evidence, and draw conclusions based on their observations.
It's like they're putting on their detective hats
Yeah.
and using density as their magnifying glass. I'm really impressed with how the Density Flash Applet manages to take a concept that might seem, dry on paper
Right.
and turn it into something interactive and exciting.
Yeah.
It's a testament to the power of good educational design.
Absolutely. It's a great example of how technology can be used to enhance learning and make complex concepts more accessible. And it's not just for students either,
Right.
Anyone who wants to learn more about density can benefit from using this applet. It's a great tool for exploring and experimenting with this fundamental scientific principle. It really is. And speaking of making complex concepts more accessible, let's take a moment to appreciate how elegant the concept of density is.
Okay.
It's this simple relationship, mass divided by volume,
Right.
that has such far-reaching implications in
Yeah.
how we understand the world.
It's true. It's like this underlying principle that connects seemingly unrelated things, from the way ships float
Yeah.
to the movement of ocean currents.
Mhm.
It's almost like density is this secret code that unlocks a deeper understanding of the universe.
That's a great way to put it. And once you start to see the world through the lens of density,
Yeah.
you start noticing it everywhere.
Right.
Think about a hot air balloon, for example.
Oh, yeah. They float because the hot air inside is less dense than the cooler air surrounding it.
Exactly. And that difference in density creates buoyancy,
Okay.
which is the upward force that allows the balloon to rise.
Gotcha.
It's the same principle that makes ships float.
Right.
But in this case, it's the density of the air,
Yeah.
not the water, that's important.
So density isn't just about solids and liquids. It applies to gases, too.
Yeah.
That's fascinating.
It is. And speaking of gases, have you ever wondered how helium balloons manage to defy gravity?
Well, I know helium is lighter than air, but I never really thought about why.
It all comes down to density.
Okay.
Helium is much less dense than the air around us, so it has this strong tendency to rise. That's why helium balloons float so effortlessly. While a balloon filled with regular air would simply fall to the ground.
It's amazing how something as simple as the density of a gas can have such a visible effect.
It is, and this principle has practical applications too.
Oh, okay.
For example, helium is used in airships and blimps
Uh-huh.
because of its low density. It provides lift without the need for heavy engines or complex aerodynamic designs.
So understanding density
Mhm.
not only helps us explain why things float, but it also allows us to design and build incredible flying machines. It's like we're harnessing the power of density to achieve our dreams of flight.
That's a great way to think about it. And while we're on the topic of flight,
Okay.
let's talk about airplanes for a moment.
Okay, I'm ready to take off into the world of aviation.
Right.
What role does density play in how airplanes work?
Well, airplanes rely on a principle called lift to
Okay.
stay airborne.
Okay.
Lift is generated by the shape of the wings
Right.
and the way air flows over them. The upper surface of the wing is curved,
Okay.
which forces the air traveling over it
Yeah.
to move faster than the air flowing under the wing.
Okay.
This creates a difference in air pressure,
Right.
lower pressure above the wing,
Uh-huh.
and higher pressure below it.
So the higher pressure underneath the wing pushes the airplane upwards.
Exactly. And here's where density comes in.
Okay.
The density of the air affects how much lift is generated.
That makes sense. So on a day when the air is denser, like on a cold day,
Yeah.
would an airplane generate more lift?
You got it. Denser air means more air molecules are hitting the wing's surface, which results in greater lift. That's why airplanes often have an easier time taking off and staying airborne on colder days.
Wow, that's really interesting. I never knew that that the density of the air could have such a significant impact on an airplane's performance. It's like an invisible hand helping to keep the plane aloft.
It is, and it highlights how understanding density can help us not only explain natural phenomena, but also optimize the design and operation of our technologies.
This deep dive is really opening my eyes to the importance of density in so many different areas. It's like it's woven into the fabric of our world, connecting everything from the smallest atoms to the vast expanse of the universe.
That's a beautiful way to put it. And speaking of connecting things,
Yeah.
let's bring this back to the Density Flash Applet for a moment.
Okay.
One of the key takeaways from this resource
Yeah.
is that it encourages exploration and experimentation.
I agree. It's not just about passively absorbing information.
Right.
It's about actively engaging with the concepts.
Exactly. It provides a safe and engaging environment for students to test their hypotheses, make predictions, and see how changing different variables affects density. They can explore the relationship between mass, volume, and density without the constraints of a physical lab setting.
That's really valuable. It allows them to learn through trial and error,
Yeah.
which can be a much more powerful and memorable way to understand a concept than simply reading about it. It's like they're becoming scientists in their own right,
Right.
conducting virtual experiments and drawing their own conclusions.
Exactly. And that's what makes this applet such a valuable tool for teaching and learning about density.
Yeah.
It transforms a potentially abstract concept into something tangible and interactive, allowing students to connect with the material on a deeper level.
It's a great example of how technology can be used to make learning more engaging and effective. And it's not limited to classrooms either.
Right.
Anyone with an internet connection
Yeah,
can access this applet and start exploring the world of density.
it's true.
It's a fantastic resource for anyone who's curious about science and wants to learn more about this fundamental principle. It's been a wild ride through the world of density. We've seen how it explains everything from floating boats to salad dressings, ocean currents to airplanes taking flight. It's incredible how this one concept has so much explanatory power.
Right.
But before we wrap up, I'm curious, where does this all lead? What are some of the bigger implications of understanding density?
That's a great question. And it takes us, beyond our everyday experiences into the realms of cutting-edge science and technology.
Okay.
For example, understanding density is crucial in fields like material science and nanotechnology.
Absolutely.
Well, by manipulating the density of materials at a microscopic level,
Right.
scientists are able to create new materials with incredible properties.
Okay.
Think about super strong,
Yeah.
but lightweight materials for building spacecraft or flexible electronics that can be integrated into clothing.
Oh, that's mind-blowing. So density isn't just about explaining what we already see. It's also about designing the future.
What else? Density also plays a crucial role in medical technology.
Yeah.
For example, in medical imaging techniques like CT scans and MRIs,
Yeah.
density differences in tissues allow doctors to create detailed images of the inside of the body. This helps them diagnose and treat a wide range of conditions.
So understanding density is literally helping to save lives.
Yeah.
It's incredible how something so fundamental can have such profound implications across so many different fields.
It is. And if we zoom out even further,
Okay.
density plays a crucial role in our understanding of the universe.
Okay, I'm intrigued.
Yeah.
Tell me more about the cosmic connection to density.
Well, think about stars. They form from giant clouds of gas and dust that
Wow.
collapse under their own gravity. As this material collapses, it becomes denser and hotter,
Okay.
eventually reaching a point where nuclear fusion begins and a
Yeah.
star is born.
So the density of these clouds of gas and dust
Yeah.
is what ultimately determines whether or not a star will form.
That's right. And the density of a star
Yeah.
also determines its lifespan and how it will eventually die.
Wow. So
Mm.
so density is literally shaping the life cycle of stars. It's amazing to think about.
It is, and it doesn't stop there.
Okay.
Density is also a key factor in the formation of planets.
Right.
As a star forms, the
Mm.
remaining gas and dust in the surrounding disk
Mm.
can clump together,
Okay.
forming denser and denser regions.
Right.
Eventually, these regions can become massive enough to form planets.
So the planets in our solar system, including Earth, owe their existence to the principle of density.
You got it. And the density of a planet determines its composition, its gravitational pull, and even whether or not it can support life.
This is blowing my mind. It's like density is this invisible force that's shaping the universe at every scale, from the tiniest particles to the largest celestial objects.
Right.
It makes me wonder what other mysteries density might hold the key to unlocking.
That's the beauty of science. There's always more to discover and explore.
Yeah.
And who knows what incredible insights await us as we continue to delve deeper into the mysteries of density.
This deep dive has been an incredible journey. We've gone from everyday examples like floating boats and salad dressings to the formation of stars and planets.
Yeah.
It's amazing how one simple concept can connect so many different things.
It is.
I feel like I have a whole new appreciation for the power of density.
It's been a pleasure exploring this with you, and hopefully our listeners are feeling inspired to look at the world around them with
Yeah.
a newfound curiosity and appreciation for the science that underpins it all.
Yeah, absolutely. A huge thanks to our expert for guiding us through this fascinating world of
It
density.
is my pleasure.
And to you, our listener, thanks for joining us on this deep dive.
Yeah, thanks for listening.
Keep those brains buzzing, and remember, density is everywhere. We'll catch you on the next episode of The Deep Dive.